Hello. We will quickly convert this whatever the previous program add.c, right, into a floating point type. Yeah. So we will just copy this, create new one, copy this as it is, and let me save this as add. But now I'll call this as add underscore f.c just to say that it is floating point type. Yeah. Or I'll simply say add 2.c. Yeah, something like this. So now I have same program, but I will convert it into a decimal type. Okay. So for that, first thing I'm going to change is instead of int, now I will use a keyword called float. Float in C programming or in most of the programming languages, float indicates real numbers. Yeah, with the decimal type. Yeah, float number one, two, result one, result two. So what I mean here is I wanted to have four variables, result one, result two, number one, number two, but those four variables should hold floating point numbers. So floating point numbers can hold even integer numbers also, but integer numbers cannot hold floating point. They cannot support decimal numbers. So floating point number can hold 2, it can hold 2.5, it can hold 2.5367, everything. Yeah. So now I'm saying enter two numbers. Now scanf in number one, number two, I wanted to store, but this time it is not percentage %d, instead it is percentage %f. Yeah, because these are floating point. If it is integer, percentage %d. If it is floating point, it is percentage %f. Yeah. Now results are same. And while you are printing also, it is going to be percentage %f. Yeah. So I will replace everything with percentage %f. Now this will become floating point type. Now let's try to compile this. Add 2.c. It is compiled. Now run it. Add two numbers. 2.5 is another number. 3.5. Yeah. I can see 2.5 plus 3.5, 6. Yeah. 2.5 minus 3.5 minus 1. 2.5 into 3.5, this much. 2.5 divided by 3.5, this much. Yeah. But now you may be wondering why so many zeros, extra zeros. Yeah. So for that, if you want, you can always truncate. You can always say, I want only two decimal numbers after, only should display only 2 digits after the decimal number. For that, there is a special format. It says 0.2f. Yeah. So 0.2 indicates I wanted to display basically after decimal point only 2 digits. Okay. Now I'm changing it to only one just to show you the difference. Recompile. Yeah. Let me clear it. Okay. 2.3 and another one is 4.6, and you can see that 2.3 is now shown as 2.30 plus everything else. So if you want, you can always change it 0.2f, 0.3f, whatever the way you wanted to show it, right? So that way you can clearly show it. Yeah. Now other thing, like for example here, right? Let me make it as 0.2f. Yeah. Now clear, compile, run. 2.5, 2.3 is one number, 4.5 is another number. Now you can see your result is floating point number. Okay. Now when I run this, yeah, I can always give 2 and 4. Yeah. So this time it works. I mean, floating point number support integer type. So 2 has become 2.0, 4 has become 4.0. Of course, you can always again tune it with proper percentage, 0.1, 0.2f, whatever it is. Yeah. Now your result you can see. If it is integer type, for example, if I run add.c, okay, add.c is all integer type. Yeah. Now let me compile cc add.c. Yeah. Now a dot out, two numbers, 2 and 4. Now you can see 2 divided by 4 is 0 because it's all integer. Now if I compile add2.c, okay, and since I'm compiling without giving any output file name, it is always overwriting a dot out. So that's why I'm executing a dot out again. Yeah, but this time it is all floating point numbers, right? So same input I'll give, but you can see the result. Because it is floating point now, it is properly showing you the result. So here same input, but it was integer type. That's why it ignored the decimal portion. Yeah, but whenever you are dealing with decimal type, okay, you have to use float. Yeah, now there is another type which is called double. Of course you can use double. Yeah, and whenever you are using double, this is called long float. You have to use LF. Yeah, long float. So double is basically uh, double the precision of float. Like for example, if float takes a precision number up to, let's say, 6 digits after decimal point, double is actually double the precision of float. Yeah, if you're working with some scientific formulae, etc., which holds lot of higher precision numbers, you can use double. Yeah, so that's how we normally use floating point numbers. Yeah, so try practice this and see the different types. Try to format it in different possible ways. Yeah, thank you.